Assalamualaikum warahmatullahi wabarakatuh. So in this video, me and my team has make some box for checking the pH and temperature of the plant. That this project is connected with the hydroponics, and yeah, it's about the checking and the manage the plant. Yeah, like the farmer. Okay, and after this, I will give it to Daniel.
Okay, I'm Daniel. Then I will explain you about the definition and the concept of this project of this hydroponic system. Okay, so far the definition is uh, the hydroponic is using water, not soil. That is water is contains nutrition that will continuously through the roots where the plants or the spinach uh, will get the nutrition. Then for the concept of this project is we use a tank of water that is the nutrition water. Then we have a pump. Then the pump will pumping the water to the pipes where the plants are placed in there. Then the plants will take the nutrition from there. Then this system is maybe more save water and save space. Okay, thank you. Next to Rizky.
So this is the how it works. So the first you need to plug the cable that is power supply, connect it from the, and then it will turn on. And power supply is for the ESP32. And why we not connected directly to the ESP? Because ESP only can receive 5 volt, and power supply has more volt. And because that, we need to decrease the volt because decrease the volt from step down. And then here we have the step down will give it to the ESP. This is the cable because before we use this ESP, we have the ESP, another ESP that only connected like just like the connect like this. And then uh, this is the microbit. The code will the ESP and the microbit will have the code each. Each of this will have the code, and then we plug in here, and then it should be turn on, but I don't know why. And then it's connected to the microbit like relay the negative and the pin data. We connect it to the microbit Wi-Fi shield, and because this is a 5 volt, so it connected to the step down or ESP. I mean ESP from this. This is because it's a fin, and then it connected to the relay, and then pH meter. This is used for that we use to see the acidic. And then there is a DS18B20 that is used for see the nutrition of the water. And then there is a TDS. So TDS is, yeah, TDS meter for the check the TDS if value is correct or no. And then there is a resistor from for the decrease the voltage from, because not it will not uh, tabrakan, because this is not will, because if we not use resistor it will broke. And PCB, that is the board of like ESP and terminal pin and another. And yeah, maybe that's all. And let's go to the next person, that is Fikri Akbar.
Okay, so in this part, I want to show you how to connect your dashboard into the database in a real time. Okay, so first you need to open the VS Code and you need to write npm run dev. After that, this is your name dashboard and this is your database. You just copy it and go to your dashboard and you just yeah you just input it and it will be run like this. It will be send the real time real time yeah immediately into your dashboard. So this is why this is nothing, yeah, because I'm still haven't connected. You just need to connect it, but first you need is make your own database. Okay, this is the structure JSON. Okay, if you want to see it like this, yeah, this is the structure JSON. Okay, maybe that's all from me.
Alright, so I'm going to show you how the code works. Start from Arduino IDE. So, in here for the first is credential sesuaikan dengan data. This work is for this section stores the Wi-Fi credentials and Firebase config. The ESP32 use this value to connect the internet and communicate with the Firebase real-time database. And then for the second section is used for to handle communication with Firebase. FB the OS is sends seed sensor data to Firebase. C FBDOC is for receive control command from Firebase. Auth or authenticate is for handles authentication, and for config is stores Firebase setting. And then in the third section, there's void setup. This setup function runs only once when the ESP32 start main task. Initialize serial communication, establish communication with the microbit of serial 2, connect to Wi-Fi, configure Firebase, connect ESP32 to Firebase. This ensures ESP32 is ready to exchange data with both to the microbit and Firebase. And then in the fourth section, this function is simply sending sensor data to Firebase process, create JSON object, store information such as sensor type, sensor value, maximum limit, unit, upload the JSON data to a specific Firebase path. Alright. Next, in the fifth section, if serial available, here, okay, the ESP32 checks whether the microbit has sent new data. Example, receive data. pH-nya 68, TDS 1200, water temp 25.3, temp 28.1, humidity 75. Read the message, extract each sensor, convert the value into number, upload them to Firebase. Data sent. pH level, TDS, nutrient concentrate, water temp. And then the next is logic. If value 1, send on to the microbit. Alright. And then we're going to move to the next. Is it a microbit? Alright. For the microbit is this section configure for the first section, yeah, serial ready serial pin 8, pin 12. This section configures serial communication between the microbit and ESP32. P8 equal TX or transmit, and then P12 equals RX, receive. Baud rate the microbit use this connection sensor data to the ESP32. Second is LCD initialization. I2C LCD init. This thing. Okay. The LCD 1620 display is initialized of the I2C interface. At startup, the system displays system hydroponic project for 2 seconds before clearing the screen. Purpose: provide a startup message, indicate that the hydroponic monitoring system is running, and then for the third section, is pH sensor calibration function. Input on button and press button here. Sorry. Okay, on button. All right. These functions are used to calibrate the pH sensor. Button A, calibrate the sensor using pH 6.8 buffer solution. And then button B used for calibrate the sensor using pH 4.01 buffer solution. And then button A plus B calibrate the sensor using pH 9.18 buffer solution. Purpose: improve pH measurement accuracy, adjust sensor reading based on standard solution. And then in the fourth section, this system continuously read pH sensor, measure water acidity or alkalinity, TDS sensor. And then in the fifth section, or we can say if temp water 28, sorry. Okay. The system automatically control a relay connection to pin 10. Logic: water temperature above 28, pins digital write pin 18, relay on, pump or we can say cooling system on, display large square icon. Alright, and then in the 7th section, this microbit package all sensor reading into a single string. Example: pH 9.8, TDS 1200, sorry, and then for the temp to 5 and 30, right? And then for the last section is continuous system loop. Here, the system repeatedly perform the following task. All right, maybe that's all for me, and we'll continue to the next explanation.
Okay guys, so now I will show you our hydroponic system. Okay, so let's start from here, from the hardware. As you can see in here, there's a power supply. Then there's a step down in here. It's for turn down the electricity to become 4.96. So in here, it will going to the ESP. Then from the ESP, it will going to the microbit and Wi-Fi shield. Then there is a DHT for the humidity. Then there's a okay, so this is a relay. Okay. Then this for the TDS meter, as you can see. Then this for the pH meter. Wait, this already I put it in here. Okay, now let's see the system in here. Here there is from the power to the pump. It will pump. It will pumping the water into this pipe. Then it will go. It will touch the plant. The name of this plant is spinach. Then the name is net pot.
Then in the under of the spinach there is a rock wool. Okay, so the water will going down, follow this pipe until going down, then go back to this balloon. We can say like a replay or recycle. Okay, thank you.
So, IoT hydroponics is a modern farming solution that combines Internet of Things technology with hydroponic system through sensor and automated monitoring. Plant condition. Plant condition can be observed in real time, making plant growth more optimal, efficient, and resource saving. And the system then demonstrates how technology can improve agriculture productivity in the future. Yeah, so maybe that's all from our presentation about IoT hydroponics. We hope this innovation can be profit benefits and inspire the application of technology in agriculture. And we apologize if we made a mistake. Assalamualaikum warahmatullahi wabarakatuh.